We will now discuss the solution of a problem from the section Applications of Binomial Theorem. And this problem has appeared in JEE Main examination held on 25th July 2021 in the second shift. The problem is the lowest integer which is greater than 1 plus 1 by 10 to the power of 100 whole to the power of 10 to the power of 100 is, the four options are given to us. Let's now discuss the solution of the problem in detail. Let I is equal to 1 plus 1 by 10 to the power of 100 whole to the power of 10 to the power of 100. Let n is equal to 10 to the power of 100. Then I will be equal to 1 plus 1 by n whole power n. Let us expand this by binomial theorem. This will be equal to 1 plus nc1 into 1 by n plus nc2 into 1 by n whole square plus etc. plus ncn into 1 by n whole power n. And this nc1 is n into 1 by n is 1, and this will be equal to 1 plus 1. For the remaining terms, let us write down in the sigma notation. Sigma r is equal to 2 to n ncr into 1 by n power r. And this 1 plus 1 is 2, and this will be 2 plus a, where a is this sigma r is equal to 2 to n ncr into 1 by n power r. Let's continue. And first I'll show you that ncr into 1 by n power r, which is here, that I will show you is strictly less than 1 by r factorial, where n is a natural number and 2 less than or equal to r less than or equal to n. ncr into 1 by n power r. For ncr, the definition, n into n minus 1 into n minus 2 into up to n minus r plus 1 by r factorial, that is ncr, into 1 by n power r. And from n take out a n, there remains 1. From n minus 1 take out a n common, it remains 1 minus 1 by n. N taken out, n times 1 minus 2 by n. N taken out, n times 1 minus r minus 1 by n. And from each term, n has come out, r times n power r, that cancels with this 1 by n power r. And thus we get that will be equal to 1 by r factorial into 1 minus 1 by n, 1 minus 2 by n, 1 minus r minus 1 by n. And note down each term, 1 minus 1 by n less than 1, this is less than 1, this is less than 1, and the product less than 1, and thereby the total will be is less than 1 by r factorial. Thus I have proved ncr into 1 by n power r is less than 1 by r factorial. Now what is a? A is a sigma r is equal to n ncr into 1 by n power r. This I have shown less than 1 by r factorial, and this will be strictly less than r is equal to n 1 by r factorial. And this will be strictly less than, this summation is r is equal to n. Now we have extended r is equal to infinity. We have added infinitely many terms on the right hand side, and thereby this will be less than this. And this summation r is equal to infinity, now we have written r is equal to 0 to infinity. That means we are adding two terms, that is r is equal to 0 and r is equal to 1 we have added, that we have to subtract. R is equal to 0 will give you 1, r is equal to 1 will give you 1, that will be 1 plus 1, we have to subtract minus 2. and that will be sigma r is equal to 0 to infinity 1 by r factorial is the famous exponential and minus 2. Thus, I is equal to 2 plus a, and where a is less than e minus 2, so 2 plus a is less than 2 plus a is less than e minus 2, minus 2 plus 2 cancels, is equal to e. So thus I is less than e, where 2 less than e less than 3. Therefore, the lowest integer which is greater than 1 plus 1 by 10 to the power of 100 whole to the power of 10 to the power of 100 is the next integer. The next integer, that is 3. That is 3. So we have our answer 3 is appearing again as the option 3. Therefore, our answer is option 3. So that is the discussion of the solution of this problem by the first method. This is the first method. I will now show you second method. Let n is equal to 10 to the power of 100. Then 1 plus 1 by 10 to the power of 100 whole to the power of 10 to the power of 100 will be 1 plus 1 by n whole power n. Let's call this as the an. Thus we get an is a sequence of positive real numbers. So it is well known that this sequence an, where an is 1 plus 1 by n whole power n, is a strictly increasing sequence. I hope that you know this result. If you do not know this result, I will show you, don't worry. I will show you how this is a strictly increasing function, increasing sequence in the next slide. We proceed now. We take an is a strictly increasing sequence, that is m greater than n will imply am greater than an, that is an less than am. Therefore, an is less than am where m greater than n. Therefore, an is less than limit m tends to infinity am. Yeah. And that will be less than limit m tends to infinity of am is 1 plus 1 by m whole power m. That is exponential e, where 2 lies between where e lies between 2 and 3. 2 less than, e less than 3. So thus an means 1 plus 1 by 10 to the power of 100 whole to the power of 10 to the power of 100 belongs to 2 to 3. Therefore, the lowest integer which is greater than this will be next to this, that is 3. So that is by the method 2. Now, I will show you that this sequence an is a strictly increasing sequence in the next slide. And we have an is 1 plus 1 by n whole power n. I want to show you an is a strictly increasing sequence. We have an is 1 plus nc1 into 1 by n plus nc2 into 1 by n whole square plus etc. plus ncn into 1 by n whole power n. And this is the second term is also 1 plus 1, and we have written in a sigma notation as in the earlier slides. And we have written NCR, the formula for NCR, and 1 by n power r, and from each term we have taken out a n common and cancels with 1 by n power r, and thus we get this. Let m belongs to n and m greater than n, and we want to show you am greater than an, that is an less than a. Then m greater than n, then 1 by n is greater than 1 by m, right? And multiply throughout by minus 1. The inequality is get reversed. Minus 1 by n less than minus 1 by m. Adding 1 on both sides, we get 1 minus 1 by m less than 1 minus 1 by m, where m greater than n. Now let's now estimate an is this 1 plus this, and where this term 1 minus 1 by n is less than 1 minus 1 by m, 1 minus 2 by n is less than 1 minus 2 by m, 1 minus r minus 1 by n is less than 1 minus r minus 1 by n. Each term is less than, therefore the product will be strictly less than this. Now r is equal to 2 to n. Now we want to extend this summation from r is equal to 2 to n to r is equal to 2 to m. That means we are adding m minus n terms on the right hand side, and thereby it will be still strictly less than the earlier one. So 1 plus 1 sigma r is equal to 2 to m, 2 to m into 1 by r factorial into the product of these terms as in the last step. And what is this? What is this? 1 plus 1 sigma r is equal to 2 to m 1 by r factorial into 1 minus 1 by m into 1 minus 2 by m 1 minus r minus 1 by m is am. Is am. Thus we have shown an less than am, that is am is strictly greater than an when m greater than n, and that will show you the sequence an is a strictly increasing sequence. So that is how we can show that given sequence an is a strictly increasing sequence. So that is the discussion of the solution of the problem from the section Applications of Binomial Theorem. I hope that you have understood the solution of this problem, and go on working out some more problems on the applications of binomial theorem. I wish you all the best. Thank you.